Namaste students. Today we are going to see an interesting topic from class 12 biology. The chapter is Principles of Inheritance and Variation. Okay, in this we are going to see a very important topic named pedigree analysis. This pedigree analysis is a study about a family history and their inheritance. It's a very strong tool which can be utilized to find out the specific traits, abnormalities or diseases, and it is very useful for the genetic disorders, how they pass from one generation to the other. So let's see in detail about pedigree analysis. See here students, this can be divided into two types. One is autosomal disease, another one is sex-linked disease. As you all know, the genetic disorder happens because of the genetic material, which is nothing but DNA. Okay, there are two types of chromosome. One is autosome, another one is allosome. If the disease is taking place in the autosome, if there is a change, if there is a mutation in the autosome, then we can call that one as autosomal disease. Suppose if the disease is taking place in allosome, allosome means what? It's nothing but sex-linked chromosome, that is called allosome. If there is a change or mutation in this allosome, then we can call that one as sex-linked disease. Okay, are you all clear with this? What is meant by pedigree analysis? And two types like autosomal disease and the next is sex-linked disease. Okay, now let's move on to the next part, that is dominant disease and recessive disease. Dominant disease means which will never skip the generation. For example, if the parents are affected, definitely the children will be affected. So it will never skip the generation. That is called dominant disease. Then what about recessive disease? If the parents are not affected and their children are affected, or suppose if the children are not affected and the parents are affected, then we can call that one as recessive disease. They will skip the generation. Okay, so these are the two types of diseases. One is dominant disease, another one is recessive disease. Fine. Now let's move on to the types. Genetic disorders, there are two types. One is Mendelian disorder, another one is chromosomal disorder. What is this Mendelian disorder? Mendelian disorder means there will be a change or mutation in single gene. If single gene is affected, then we can call that one as Mendelian disorder. So many diseases are there. One best example or famous example is hemophilia. This was noticed in Queen Victoria's family. I'll teach in detail about hemophilia in the next class. Now let's see about the other type, that is chromosomal disorder. Here we can see there will be a loss or gain of chromosomes. So many types of disease will come under this particular chromosomal disorder, like Down syndrome, Turner syndrome, Klinefelter syndrome. Everything I'll teach you in the next class. But before that, let us see about hemophilia in detail. So hemophilia is a Mendelian disorder and it is also called bleeder's disease, because if the particular person is affected due to hemophilia, if he get hurt, the blood will not clot. It will continuously bleed. So it is called bleeder's disease. And do you know which chromosome is affected because of this disease? That is X chromosome. If the X chromosome is affected, then it can be called as X-linked disease. Already I told you sex-linked disease. Do you remember? Sex-linked disease means nothing but it is related to allosome, that is sex-linked chromosomes. So now here the X chromosome is affected. So this can be called X-linked disease. Which one? That is hemophilia. And now you can see here I have written XHX. You know very well XX stand for female. And I have written H here. So it is understood this particular X chromosome is affected. But this is not affected. So this female will be a carrier and not affected. Suppose if both the X chromosome are affected, then she is affected women. And notice here XHY. We know very well the sex chromosome for male is X and Y chromosome. I have written here XH. That means that particular X is affected. So the male is a hemophilic male. Understood clearly about how the hemophilic person gets affected due to which chromosome, everything. Let's see an example. See here I have written a chart where normal father is there, X and Y, and they both get married. This is female, she is a carrier. If they both get married, just see about the offspring. What happens? If this and this joins means the daughter will be a carrier. If this and this joins means the daughter will be normal. She will not be affected. If this and this joins means the male will be affected. Already I told you the male will have only one X chromosome, and if that is affected, definitely he will be a hemophilic person. So the son will be a affected boy. So students, now we noticed here Y and X. If they join, it will be a normal son. I think now you understood the hemophilia clearly, and let's see in detail about all other diseases in the next coming classes. Thank you students.